we are looking at learning objective 13 to draw and label energy diagrams for endo and exothermic reactions. So an endothermic reaction, endothermic. This means we have to add heat, right? So we add heat. So we're adding energy here. So that means that my system is heating up, my surroundings are cooling down. Okay, so in the reaction, you have any energy reaction diagram. You have energy here, and you have the reaction progress or energy diagram. You have the reactants, you have the products, you have the enthalpy of the reaction, which is the heat energy divided by the moles for the reaction, and you have the activation energy. So these are the four things that you need to have in your energy diagram. Not only that, but you also have to have your energy, like your labels on your diagram labeled, like your X and Y axis labeled. So let's take a look at this. So then if I have going from low energy to high energy, so on an endothermic reaction, we're going to start a little lower on the diagram. And then we have this big hump. And then we have another line. So it goes straight across right there. Okay. So then this starting is my reactants. These are my products. Okay. Now I can draw a dashed line all the way across the bottom of this one. Okay. From here to the top of the loop, from here to the top of the loop, we have what is known as activation energy. So this is the energy that we have to use to break the bonds in the reactants. So anytime you have bond breaking, it is an endothermic process, always. And it is caused because the bonds are breaking. And then we have this area here. So from here to here, this is my added heat. So this is my added Q, which means that I have a positive delta H. So delta H, like I said before, is equal to the heat energy divided by the number of moles. So this is number of moles. Okay, so if I've got a positive delta H, that means it's endothermic reaction. Okay, so activation energy, reactants, products, heat plus Q plus delta H. So all of this is my delta H right here. Okay, and then if we are looking at an exothermic reaction, so exothermic reaction, we're going to kind of have the same thing, except for we're going to start high energy because an exothermic process starts high and ends low. So we have this guy, right? Again, it's the same thing, right? I have my reactants here because that's what I'm starting with. My products are here. And then I can draw kind of a dashed line here, and I can draw a dashed line here. Okay, so then my activation energy is just from here to here. So this area is my activation energy. Which is my AE. We abbreviate it as capital AE. Now, so again, we are still having to break the bonds. This is an endothermic process. So this part right here, I'm having to add energy to get those bonds broken. Now, the overall reaction here is exothermic, which means I'm releasing energy from this point to this point. So this is going to be minus Q, which is a minus heat, which is a negative delta H. So again, that negative delta H value is Q over N, right? So if I've got a negative delta H for the reaction, then it's going to be exothermic. Okay. So activation energy is the energy required to break the bonds of the reactants. This is always endothermic. Breaking bonds is endothermic. It's never exothermic. Making bonds is exothermic. So making the bond itself is exothermic. Overall reaction can be either endothermic or exothermic. But again, breaking bonds is endothermic. Making bonds is exothermic. You can have a catalyst. All a catalyst does is it lowers the activation energy, speeds up the reaction. Here that you're probably not as familiar with. This is the delta H, this heat lost or gained by the reaction. So again, this guy is like your Q over your N. That's what this guy's related to. So do delta H. So plus delta H. This is an endothermic or endothermic reaction. And if I have a negative delta H, this is an exothermic process. And you can kind of look at these guys and say, okay, well, if delta H is positive, then that means that Q is positive. And if delta H is negative, then that means that Q is negative. Okay. So that is the difference between endothermic and exothermic reactions. You should be able to draw an energy diagram labeling the axes, activation energy, reactants, products, and the enthalpy of the reaction. So delta H is enthalpy. I think that's one thing that I forgot to mention, but this guy is the enthalpy of the reaction. So it's enthalpy, but it means heat. It's the heat gained or lost by the reaction. All right, and that is the end of chapter 3.